In this video, I'm going to prove to you the product rule. So, we've got two functions we multiplied together. I think the best way to do this is to use the limit from first principles, which is the limit as h tends to 0 of, here we go, f of x plus h, g of x plus h, minus f of x, g of x, all divided by h, which is the limit as h tends to 0. Now, you'll have to probably expand that out, and that is pretty nasty. There's not really many ways you can deal with that. In fact, I won't put it there, I'll put it on the following line, because I'm going to need a bit more room, probably. So we've got f of x plus h, g of x plus h, we've got that bit, plus, now the way to do this is to add a term and then get rid of it. So, x plus h, and then if you multiply by g of x, and then take that away, yeah, we know that's going to cancel, but it will enable us to basically solve this problem. And then we take away f of x, g of x, all divided by h. So we can see this coming together, which is quite good. Which is the limit as h tends to 0. You have to keep writing the limit, that's something I stress to all my kids. Got f of x plus h times g of x plus h. No surprises there. Take away f of x plus h, and then times by g of x. Yeah, that's right. You have to kind of second guess yourself when you can't do these, but you'll be fine with them, don't worry. Then I'm going to have a plus in there now, because I've got a double negative, of f of x plus h times g of x minus f of x times g of x. I'm going to put on a big bracket altogether. So I end up now with that, and then it enables us to split this limit up. We've got the limit as h tends to 0. There's two limits. I can split them up into each of its bits, as per se. So I'm going to put one side to one, and I'm going to stick one side to the other. So we've got fx plus h, g x plus h, minus f of x plus h, g of x, all over h, plus the limit as h tends to 0 of f of x plus h, g of x, take away f of x, g of x, all over h. Yes, this is the proof of the product rule, just as you're wondering there. So, nearly there now. I just need to break these limits apart, essentially. So to break them apart, I'm going to actually bring these out of the front, like so, and then I'm going to multiply them by the rest of it. So g of x plus h minus g of x all over h, which we know what this will be. This will be g prime, as per se, yeah? Then we've got the limit as h tends to 0 of, we can factor, hello, g of x can come out the front. And then we've got the standard form that we know. That'll be f prime, right? So we've got g of x f prime, and we've got g prime, and then we've got f of x plus h. So I can basically now put this together, as per se. That can go in a bracket together. Then we've got the limit as h tends to 0 of g of x plus h minus g of x all over h. Then we add the limit as h tends to 0 of g of x. And then we've got the limit as h tends to 0 of f of x plus h minus f of x all divided by h. And hello, we have now finally proved the product rule, because we have f of x times g prime of x plus g of x times f prime of x. Whew, pat on the back for me. That's tough. It's a lot of algebra going on here, but this is the proof of the product rule. You do not have to learn this, but you could well be asked, prove the product rule from first principles. It might come up. Or prove the derivative of f of x times g of x is. So it could come up, we don't know, but it's nice. We've got a video up on YouTube, and now we need to prove the idea of the product rule. In the next video, we're going to go through some examples of using the product rule. Something way less hard.